Ever needed to build something great but you didn't have the right tools? Imagine you have wood trying to build a chair without a saw or a hammer until someone lends you exactly what you need. That's how dependency injection works in programming. Stick around and we'll break it down with a real world analogy and some TypeScript code. Alright, let's meet Rob, who wants to build this chair with these wood planks, but he don't have the right tools. Fortunately, Bob, his neighbor, has all the necessary tools required to build chair. So now Rob goes to Bob, gets these tools and build this shape, right? So if you see here, Bob is giving all the tools required at the time to build this shape. In the world of coding, Rob is like our main object and the tools he need are like the dependencies. Instead of Rob as an object have to go out and get these tools, Bob provides them as dependencies directly. And that's what dependency injection is all about. Now moving on to the real world analogy as in code terms. Now you can see we have one class as saw, right? And we have a function as cut and it's just simply printing cutting the wood. And also we have similar class that is hammer and we have a method as hammer nails and hammer and the nails is just logging. Okay. Now if we go down, we have a chair builder. Now this you can treat that as a rob and we have defined two fields saw and hammer. Okay. And in the constructor it is expecting two arguments, one the saw instance and the other one is the hammer instance. And this class has a method build chair, this dot saw dot cut and this dot hammer nails, and at the end we're just printing chair is built. That's it. Okay. Now if you see down as per the actual implementation, first I'm creating a new instance of saw and creating another instance of hammer, then I'm passing these two over here, right? And now I got the chair builder as one Rob instance, let's say, and Rob builds the chair. And if you see as per the output, cutting the wood, hammering the nails, and chair is built. That's it. This is simply a dependency injection. There are a few things we can improve on. I'll cover those shortly. Now I'll just give you an example like without using any dependency injection. If you can see here in the chair builder class, we have two properties, saw and hammer, and that specific instance. And we don't have the constructor also. And if you can see here, build chair function definition is exactly same. Just that how these dependencies are loaded is the point. This is one way of defining the dependencies. There's another way in the constructor don't accept any arguments, just that it will blindly create these two instances directly in the constructor. Now if you can see here, we're tightly coupling saw and hammer to the chair builder as dependencies. Yes, I agree, they are dependencies, but now imagine if you want to use different version of saw or different version of the hammer which has more power so that you can quickly build the chair. In that case you need to alter this class definition, which is again not a good practice. Now let's move on to the more relatable code. You can see here we have a service user service where we have a method get user and it's currently returning id1 and name as Vivek Bartha. This specific static line is for the sake of example, but here ideally you would be having a repository, right, or any database model helper function so that it will get the current user or as per the business logic. Okay, now moving on to the next code block, that is user controller. So if you see here, user controller is like a main object now, right? So now user controller needs a user service so that it can fetch user. That's it. So user controller has get user info, and here if you see it is using user service, which is a dependency for the user controller. Okay, and as for the above example, if you can see here in the user controller we have a constructor and it is accepting user service, so that is actually assigned to the this dot user service, so that whenever get user info function is called of the user controller, it calls user service get user function and it prints accordingly for now as per the example. Okay, now if you look at the actual implementation, so first I'm making sure I have a user service instance and then I'm passing this user service instance to the constructor of user controller, so that whenever I call get user info inside the function definition over here, it will call user service dot get user. So if you see here, I'm injecting this user service into user controller. That's dependency injection. And also the output over here, if you see get user info, just printing user info colon user dot name, and so output would be user info colon Vivek Partha. If you can see here, we need to make sure user service instance is created and that instance is passed to the user controller. But what if we could make this process even easier? Imagine if a Node.js app had a system in place that automatically knows which service the controller needs and provides it without us manually passing it down. That's where an IOC container or inversion of controller container comes in. Let me show you how an IOC container can be defined. If you can see here, these two blocks are exactly same. The user service and user controller. The two definitions are exactly same. Now if you can see here, the IOC container, we are using a map for now. And if you can see, there are two methods. register, and resolve. Now in the register, it's just simply setting a key as a dependency name and that instance as a value inside the map. That's it. Now if you can see, the resolve is simply getting that instance based on the dependency name. So simple IOC container, it will maintain internal map. We have two functions, which is kind of a set and getter. The terminologies are register and resolve. Now if you can see here, first I'm creating an IOC container instance and I'm registering a user service as a dependency and I'm just passing the class. So whenever you call this register inside this map, this IOC container will make sure that it will create a record with key as user service and one instance of user service class itself. When I'm creating a user controller, I'm just calling container.resolve user service. So this IOC container will make sure it will return the proper dependency based on this dependency name. Again, you might think that, okay, it's almost same as above, just that instead of creating the new user service, I'm just calling over here. But if you look at the big picture, like the actual implementation in the framework level, like Nest.js or any other framework where it does support dependency injection, the core crux is you can have a class and you can mention some decorators stating that okay, this is kind of an injectable. So the root framework level IOC container will make sure it will create an instance with that specific dependency name, and whenever we pass it down as a dependency or mark it down as a dependency again with a decorator or any other means, the IOC container makes sure that whenever that specific class instance is being created, it will pass it down all the necessary dependencies. So in this specific case, it might not give you the proper better picture, because more or less it's like we are just creating a user service over here, and here instead of that we are just creating a IOC container and then registering, and here you are simply getting the same class instance. So in this specific case, it doesn't have much of a difference. So when you're writing code within the framework, you don't need to make sure create this IOC container and register and all that stuff. So the framework will take care of it. And whenever you define a user controller, here you can mention in, there are so many ways. One is like a decorator pattern where you mention over here is as a dependency, right? So IOC container will scan whenever you're trying to create this specific user controller instance. It will identify all the dependencies and it will inject those automatically. And that's dependency injection with or without using IOC container. Whether you're manually passing the dependencies or using the IOC container to automate the process, the goal is same. Keep your code modular, maintainable, and easy to extend. Now moving on to the downsides of using dependency injection. First point I can think of is performance overhead on an app startup, because let's say there are like so many dependencies across the whole application, so the IOC container need to make sure that all the dependencies are in place and are ready to be resolved. Second point I can think of is in simpler applications, dependency injection can be an overkill and can lead to unnecessary complexity. Not every application needs dependency injection, and sometimes simpler patterns can be more appropriate. Overall, dependency injection is a great design pattern that, when used correctly, can greatly improve flexibility, maintainability, and testability of your code. However, it's very important to balance its use to avoid unnecessary complexity. If you found this video helpful, be sure to hit that like button and subscribe for more interesting content. And drop a comment below if you have any questions. Thank you so much for watching. Happy coding. I'll see you in the next one.